Hi, I'm Aishnaz and I will be talking about RFID tags and general information about them. To start with, we should know what RFID means. RFID is radio frequency identification, which is the wireless use of electromagnetic fields to transfer data from the purpose of automatically identifying and tracking tags attached to the object. Because of the misunderstanding of RFID, these tags often get confused with barcodes. A barcode is an optical machine-readable representation of the data relating to the object which it is attached. Originally, barcodes systematically represented data by varying the width and spacing of parallel lines and may be referred as linear or one-dimensional. Manual intervention of the reader is needed to scan the barcode line inside. These barcodes are tight and true, integral to most manufacturing and logistic processes, and they are inexpensive. However, RFID tags can be read as long as it is within range of an RFID reader, so it is much faster and can be read without human intervention. The info that barcode can store is limited contradiction to the RFID. In RFID, high memory tags can store aircraft component history over decades, so it is more expensive than barcodes. These tags are simple to integrate into enterprise systems. There are generally two types of RFID tags. These are active and passive RFID. Active RFID and passive RFID are fundamentally different technologies that are often evaluated together. While both use radio frequency energy to communicate between a tag and a reader, the method of powering the tags is different. Active RFID uses an internal power source, battery, within the tag to continuously power the tag and its radio frequency communication circuitry, whereas passive RFID relies on radio frequency energy transferred from the reader to the tag to power the tag. Active RFID tags have a transmitter and their own power source, typically a battery. The power source is used to run the microchip circuitry and to broadcast a signal to a reader, same as the way a cell phone transmits signals to a base station. Active RFID allows very low radio frequency beacons to be received by the reader because the reader does not need to power the tag for the tag to respond. Additionally, the active RFID tag is continuously powered, whether in the vicinity of the reader or not. Active tags can also beacon or initiate communication with the reader or other tags when certain conditions are present. Active tags contain external sensors to monitor temperature, humidity, motion, and other conditions. It can be read at distances of 100 feet or more, greatly improving the utility of the device. It may have other sensors that can use electricity for power. However, the tag cannot function without battery power, which limits the lifetime of the tag. The tag is typically more expensive, often costing $20 or more each. The tag is physically larger, which may limit applications. The long-term maintenance cost for an active RFID tag is greater than those of a passive tag if the batteries are replaced. Battery outages in an active tag can result in expensive misreads. Active tags can be used for tracking containers, medical assets, or monitoring environmental conditions in data centers. Passive tags have no battery. Instead, they draw power from the reader, which sends out electromagnetic waves that include a current in the tag's antenna. Passive RFID requires stronger signals from the reader, and the signal strength returned from the tag is constrained to very low levels. The tag functions without a battery. These tags have a useful life of 20 years or more. The tag is typically much less expensive to manufacture. The tag is much more smaller. Some tags are the size of grain of rice. These tags have almost unlimited applications in consumer goods and other areas. However, passive tag can be read only at very short distances, typically a few feet at most.
created using Powtoon.